Hello and good morning. You're looking at a live view of Starship, the world's most powerful launch vehicle and by far the biggest flying object ever made. We're currently at T plus 31 minutes and 24 seconds awaiting our third flight test of Starship from Starbase Texas, or what we here at SpaceX like to call the Gateway to Mars. Thanks for tuning in. We're excited to be joining you from SpaceX headquarters in Hawthorne, California. Now it's just been 100... You can tell the crowd is already excited behind us. Now it's only been 117 days since our last Starship test. And for those of you following along, you'll know there's nothing more exciting, as you can hear, than to watch a developmental flight test.
That's absolutely right. Flight test days guarantee the maximum level of excitement, as you can hear behind us. And if it all goes well, Starship will lift off just about 30 minutes from now. We're hoping to surpass what we achieved in flight test number 2 back in November of last year. But regardless of today's outcome, the goal is to collect as much data as possible, and that'll help us get one step closer to a fully operational Starship. Now, Starship, which you see on your screen, is the latest and largest vehicle developed to date by SpaceX and in the world ever. Compared to Saturn V, the rocket that first took astronauts to the moon, Starship has more than twice the thrust, and with some upgrades that are planned for the future, it'll have 3 times the thrust.
Starship will allow us to fly the heaviest payloads ever flown, land humans on the moon again after more than a half century, and ultimately fly humans further into space than ever before, even to Mars. But the most important thing about Starship is that it's designed to be a fully, rapidly reusable, reliable rocket, or what we like to call the 4 Rs, and we'll talk more about those later in the webcast. But before we dive into the details of today's test, let's recap the achievements of our last integrated flight test, Flight 2. All 33 Raptor engines on the Super Heavy booster started up successfully and, for the first time, completed a full duration burn during ascent. As you can see here, we saw amazing views of each Raptor engine burning during that ascent, which is something awesome because we don't get to see that with Falcon and its Merlin engines.
Now, next, Starship executed a successful hot stage separation, powering down all but 3 of Super Heavy's Raptor engines and successfully igniting the 6 second stage Raptor engines before the vehicle separated. This is the first time this technique has been done successfully with a vehicle of this size and scale.
Following separation, the Super Heavy booster successfully performed its flip maneuver and initiated the boost back burn. However, about 30 seconds into that burn, it experienced a rapid unscheduled disassembly, or RUD. That's SpaceX speak for an exciting end to the booster's journey. The likely cause was determined to be filter blockage, where liquid oxygen is supplied to the engines. So we've upgraded hardware inside the oxygen tank to improve filtration capabilities in our boosters, including the one that's out on the pad today. Vehicle breakup occurred more than 3.5 minutes into the flight, about 90 kilometers over the Gulf of Mexico, so well away from people.
Now, on Starship, the 6 second stage Raptor engines all started successfully at separation, and everything was going normally in the ship's climb to space until about 7 minutes into the flight, when we began a planned vent of excess liquid oxygen propellant. To simulate the mass of a payload and get future-focused data, the ship was loaded with extra propellant that we needed to get rid of or vent before re-entry. Once we started venting, though, a leak developed that caused fires, which eventually cut the connection between the flight computers on the ship, and that caused the 6 Raptor engines to shut down before we had finished the full burn. That was detected as a mission rule violation by the Autonomous Flight Safety System, which triggered the flight termination system and led to vehicle breakup.
Starship's second flight test nearly completed its full duration burn. It ended at an altitude of about 150 kilometers and a velocity of 24,000 kilometers per hour, officially making it the first Starship to reach outer space. Like the booster, we've made upgrades to Starship's upper stage based on Flight 2 learnings, such as improved leak reduction, fire protection, and changing the operations to increase reliability.
Now, back at the launch site, the new water-cooled flame deflector and other pad upgrades performed as expected, so the pad required minimal post-launch rework. And that's a big reason why we are ready to fly again today. The ground support systems are designed for rapid turnaround of the launch pad between flights, and the improvements we've made ahead of Flight 3 are getting us closer to that goal. And that brings us to today's test. The test profile and the burn timeline are very similar to test number 2, with one major difference. The ship will attempt to splash down in the Indian Ocean rather than the Pacific. This puts us on a steeper trajectory than past flights and lets us test capabilities that we'll need for the future, like lighting a Raptor in space while maximizing public safety. So let's take a closer look at the flight test profile. Now, about 26 minutes from now, Super Heavy will ignite its 33 Raptor engines and lift off from Starbase. About 3 minutes into the flight, Super Heavy's booster will separate from the ship in SpaceX's second ever attempt at a hot stage separation. That means it'll light its engines while still attached to a partially lit booster. The ship's engines will then remain lit for about 6 minutes during the ascent before entering a coast phase.
Next, the booster will perform a flip maneuver and execute a boost back burn, which, if you recall, is where Flight 2 Super Heavy experienced a rapid unscheduled disassembly. We're hoping hardware upgrades made for this flight will get the booster closer to executing a landing burn in the Gulf of Mexico. In the meantime, Starship will coast for about 30 minutes at altitudes between 150 and 235 kilometers, and the ship will attempt to fire a single Raptor engine for our first ever relight of a Raptor engine in space. And from there, the ship will head toward its destination, splashdown location in the Indian Ocean. Again, if we get past a successful stage separation and a full ascent burn with the upper stage, it will be at an added altitude and trajectory below orbital, meaning Starship won't have to fire its Raptor engines for a deorbit burn, and it will naturally come back into the atmosphere no matter what.
Now, meanwhile, the Super Heavy is going to attempt a landing burn before splashing down into the Gulf. And while we are going to practice a landing, we aren't planning to recover any of the hardware from Super Heavy or the ship on this flight. Now, with the exception of Falcon, this is no different from what happens with most rockets flying today that are expended or fall into the ocean after they complete their mission. Eventually, though, we will land and recover Starship boosters and ships, just as we do with Falcon 9 and Heavy boosters, where we've recovered 283 to date. Starship's rapid reusability is key as we begin missions to the moon and beyond.
Even though recovery is not planned, the telemetry and data we receive all the way to the end is what we're looking for, particularly with regard to the ship's temperatures during reentry and how the heat shield will perform. The data that we gather today, of course, will help us continue to build a rapidly reusable Starship for the future. Now, much like our first 2 flight tests, today also still just a test. Our goal is to gather data to continue iterating and ultimately improve Starship.
That's exactly right. The primary goal for Flight 1 was to clear the pad, and we did that and got a lot of great data that helped us improve the vehicle and the pad infrastructure that you see today. The primary goal of Flight 2 was to get all the way to stage separation, which we did, and even got a little extra.
For Flight 3, we've added some ambitious tests highlighted by an attempt to transfer several tons of propellant between the tanks inside Starship itself, as well as the first ever relight of a Raptor engine in space and the opening and closing of Starship's payload door. When Starship takes astronauts to the lunar surface as part of NASA's Artemis program, it will be refilled in space by a Starship tanker spacecraft before boosting itself into a lunar orbit, like you see here. Transferring a large amount of cryogenic liquid in space has never been done by anyone, ever. So we'll be looking to get data on some of the fundamental physics in play here, like managing pressures, temperatures, propellant settling, all as we prepare for eventual ship-to-ship transfers. The ability to refill Starships once in orbit will be critical for landing on the moon and is a key technology for enabling deep space exploration and ultimately flights to Mars.
Now, we're also attempting the first ever relight of a Raptor engine in space, and we'll need that capability for future in-space maneuvers and deorbit burns. It's important to note that what we'll attempt today is not a burn required for Starship to re-enter on today's test. We are intentionally flying this new steeper trajectory so we can test things like engine relights without substantially changing where we expect to splash down. And if Starship manages to make it all the way to re-entry, we will collect valuable data on the vehicle as it flies through the Earth's atmosphere at hypersonic speeds, or more than 5 times the speed of sound. We expect it'll look something like this animation on your screen with the heat shield tiles facing down. We'll use the Earth's atmosphere to brake the vehicle and then get us into a controllable regime as we go towards splashdown. Now, we did validate Starship's ability to fly and land at subsonic speeds during our suborbital flights several years ago. And gathering data on the aspects like heating and vehicle control while we're traveling way faster will become critical to eventually bringing Starships back from space for rapid reuse.
We'll also attempt to open and close Starship's payload door for the very first time, a capability that we'll need when Starship starts flying our next generation Starlink satellites. And there you can see an animation of what that will look like as the satellites are deployed one by one through a slot near the top of the spacecraft. So at this point in time, we are approaching T-minus 21 minutes until liftoff. Let's check in with Dan for a countdown update.
Hey, thanks, Kate. Hey, everybody. I'm Dan Hewitt. Good morning. Welcome to Starbase. I'm coming to you from the Raptor's Nest, where I'm here with some of our flight controllers, also our Pad Red team. We're just behind the Mega Bay. Those are our super heavy boosters right behind me, getting ready for the next 4 flights after this one. So we're looking to launch a lot this year. Countdown has been pretty clean so far. We're not tracking any issues that are gating us on the hardware side and the vehicle side from that on-time liftoff at 8:25 a.m. Central Time. That's our T0 right now. We primarily shifted later as we were just working to clear the range. The other big watch item today is going to be the winds. The winds have started to pick up. We're still looking to be below our limits, but there could be a hold at T-minus 40 seconds just to make sure that the winds are acceptable before we go. We are actively loading propellant on board the vehicle. You can see by the frost line starting to build up. Looks like we're about 80% on the ship main tanks right now and a little over 60% on the booster. Now, Starship uses liquid methane as its fuel, liquid oxygen as its oxidizer. Both of those get cooled down to cryogenic temperatures, so several hundred degrees below zero. And if you followed along with our previous 2 flight tests, the prop load timeline today looks a little bit different. Those first flight tests, it took us about 90 minutes to load all of the prop on board. But since the second flight, we made some pretty significant upgrades to make that time shorter. We added some additional fuel and LOX pumps just to increase our capacity. We expanded the number of heat exchangers and installed a dedicated fill drain line for each stage. But they were sharing one before, now they each have their own. That's just that main pathway to get the propellant to the vehicle. We're aiming for about 51 minutes for today's operation to fully load prop. We did that successfully on our wet dress rehearsal that we did recently. Eventually, though, we're trying to get that time down to about 40 minutes. Just for some context, that's about 5 minutes longer than we take on Falcon 9, but we're doing it with 10 times the amount of propellant. Now, the propellant load on ship started at about T-minus 53 minutes, booster right around T-minus 42 minutes. We are about to pause loading on the main tanks of ship, switch over to the header tanks, and then switch back to close out the main tanks. We're expecting all of the prop to be on ship at about T-minus 3 minutes 30 seconds, and then booster prop load ends at T-minus 2 minutes and 50 seconds. Now, our final countdown and startup sequence is going to be the same as Flight 2. We already tested this on this booster when we did its static fire. Looking back for Flight 1, we lit those Raptor engines on the booster and lifted off about 6 seconds later. Flight 2, we reduced that time by almost 2 seconds. That just helps reduce the stress on the ground systems, improve the efficiency of the rocket. But right now, we're just about to pass 18 minutes away from launch. Winds, again, they're still looking a little bit marginal, so we'll keep an eye on those. We're not working any other technical issues, and the range is expected to be green. If we can't make our test today, we have backup launch opportunities in the coming days. Could be 24 to 48 hours, all just depends on how far we get into the count. So check back in with everybody in just a little bit. For now, though, I'm going to send it back to Kate and Shiva out at Hawthorne.
Thanks, Dan. The countdown is continuing to progress, so let's take a closer look at the world's most powerful launch vehicle ever developed. Starship is comprised of 2 elements, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Starship is capable of about twice the thrust of the Saturn V rocket, and with future engine upgrades, it will actually be 3 times more powerful.
Now, with those future improvements, that'll allow Starship to carry somewhere between 150 and 250 metric tons to orbit, depending on the configuration. For reference, Falcon 9's heaviest payload to date is just over 17 metric tons. So with Starship, we're talking about an order of magnitude greater in terms of payload capability to orbit. And that matters because the amount of mass we're able to launch per rocket is critical to creating a self-sustaining city on Mars.
In terms of size, the Super Heavy booster alone stands about 71 meters or 233 feet tall and is about the same height as a fully integrated Falcon 9. The ship stands about 50 meters or 160 feet tall. Stacked together, the booster and the ship are by far taller than the Statue of Liberty, which stands at 305 feet tall with its base. Stacked together, Starship is 396 feet, so quite a bit taller there.
Now, Starship's first stage has a diameter that's about 2.5 times that of Falcon 9, and we've got those 33 much larger Raptor engines, this great view of the launch mount looking up at those engines, and we need them to power through the Earth's atmosphere and gravity to deliver those massive cargo and payloads up to space. Moving up the rocket, Starship is designed for vertical takeoff and landing on any hard surface, and that's as opposed to taking off and landing on a runway as aircraft do. And that's important because there are no runways on the Moon and Mars where we're going. The ship, which we're looking at now, features 6 Raptor engines. 3 of them are sea-level engines, 3 of them are vacuum engines. That means that those vacuum engines are optimized with a larger engine nozzle to operate in the vacuum of space and get us higher performance.
The ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing. The body of Starship is also wrapped in a heat shield made up of 18,000 hexagonal ceramic tiles. Those are designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. One of our test objectives today is to verify how Starship systems and thermal protection system tiles perform during reentry. And in between the first and second stages is our hot stage, which is critical for our newest separation technique, which we saw in action during Flight Test 2.
Yeah, that was a pretty exciting first for our team. Hot staging had never been done before as part of a reusable space transportation system, let alone on a vehicle with the size and power of Starship. Now, at about liftoff plus 2.5 minutes, the booster shut down most of its 33 engines, leaving just 3 of them running, and then the ship simultaneously ignited all 6 of its engines. Some clamps separated, and the ship thrusted away. That was the first in-flight test of the heat shield, and we were able to gather a ton of valuable data about hot staging.
We maximized the vehicle's performance by leaving 3 first-stage engines on, so gravity can't rob us of precious velocity, or at least not as much. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the propellant tanks, which is where we need them to be in order to quickly light the ship's engines. It also reduces risk at stage separation because it creates a passive staging system so that physics will be doing the work instead of mechanical parts pushing the 2 stages away from each other. Ultimately, hot staging could increase Starship's payload to orbit capacity by 10%, which directly translates to more payload and more people to the Moon and Mars.
Now, the first stop will be the Moon, and the SpaceX team has been hard at work proving out all of the systems necessary to make that possible. Critical systems for propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatches down to the lunar surface, are currently in development. And the data that we gather from each test flight helps inform their design. Here we've got a photo of some of the mock-up suits that are used to demonstrate the range of mobility that astronauts will be expected to have. And we were using these to do human factors demonstrations and figure out the layout of the elevator. So all awesome development work for a future Moon mission.
Super cool. Now, SpaceX will perform 1 uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. After those first expeditions, we'll be ready to fly more people along with everything it takes to build a moon base. There's so much to look forward to. It's incredible that humans are finally going back to the Moon.
You couldn't have said it better, Kate. And the Moon is just the proving ground. It's just the start. When the time comes to make the leap to Mars, everything ramps up by orders of magnitude. The logistics of supporting an entire city on Mars are daunting and will require millions of pounds of cargo flown from Earth and spread out over thousands of launches.
And today's flight test is one more step toward that ultimate goal. We're currently at T minus 11 minutes, 47 seconds. Let's check in with Dan once again for a countdown update.
Hey, Kate. Still good news from down here at Starbase. We're not tracking any technical issues that are going to block us to a launch. Our T0 time still holding to 8:25 a.m. Central, so just about 11 and a half minutes from now. The real thing we're going to keep an eye on is the winds once we get there. We do have that potential hold at T minus 40 seconds where we can hang out and either let winds die down, make sure we're in the right structural limits, everything like that. So don't be surprised if we do a hold at T minus 40. We've done those on previous flights, but we are not tracking any technical issues. The range is going to be green for launch, so all of that really great news. We're still loading propellant on the vehicle, on the ship. We're just about done loading the header tanks, the two smaller tanks in the top, and then we'll go back to the main tanks. Are about 85% full, and then booster, both fuel and LOX over 80%. So looking good there. The launch pad itself is getting ready for liftoff. We commanded the booster hold downs open already about 20 minutes ago or so. And then that just means that once that rocket has sufficient thrust to overcome its weight, your thrust to weight ratio goes over 1, it's going to lift off. We don't have a command to actually release the hold downs once it starts up. Just also a reminder, actual liftoff happens a few seconds after you see those engines ignite. So you'll see fire, and then a few seconds before Starship really starts to take to the skies. Our range team just going to keep on making sure land, sea, air are all clear as we really count down. But that's the latest. We're just coming up on 10 minutes before launch. Everything looking good for Starship's third test flight. I'll toss it back to you guys in Hawthorne.
Great, thanks, Dan. Now, if you've been following SpaceX over the years, you've no doubt heard us talk about our goal of full and rapid reusability. Nearly all of the Falcon boosters flown last year and this year have been reused, or as we like to say, flight proven.
We've landed Falcon 9 and Falcon Heavy boosters 283 times since first doing so in 2015. And with Starship, our mission is to take reusability even further by reflying both stages with little downtime between flights. And we plan to fly as often as possible. As we mentioned earlier, rapid and complete reusability is critical to enabling routine spaceflight. The team at Starbase has been hard at work developing and manufacturing the hardware that will ultimately take humans back and forth to the moon and Mars.
Now, even though we are not recovering Starship today, test flights like these provide the critical data that we need through every phase of flight. And that data informs future missions and gets us to that future where Starships are being recovered and rapidly reflown.
Our teams are also working on the ground systems that will support rapid reusability. When we start recovering Starship boosters, we'll want them to return to the launch site for a quicker turnaround, as you can see here depicted in this animation on your screen. This is when the tower reveals its dual purpose. After launch, the arms or the chopsticks on the tower will help guide the booster into position to ensure a soft landing. Now, if you're thinking that this sounds hard or even impossible to do, well, that's the inspiration for naming them chopsticks. Some of you might recall a little film called The Karate Kid, where Mr. Miyagi famously taught the main character, Daniel, that if he could catch a fly with chopsticks, he could accomplish anything.
Now, today we do have 4 ships and 4 Super Heavy boosters built, with more coming off the production line as our Star Factory continues to grow. These vehicles are slated for future flight tests just like today's, and in fact, just this week we static fired our next ship that's planning to fly and expect to test the booster as soon as the launch mount is free from today's flight test.
Now, as a reminder, today is still just a test. While we really hope to get our splashdown location in the Indian Ocean, but any data received will help us improve. It's the third of many future flight tests for Starship before it becomes fully operational.
And that's the goal of flight tests. They teach us about the limits of our design and improve our understanding of the vehicle, and ultimately help us make Starship more reliable and rapidly reusable. So whatever the outcome and however far we get, we can promise excitement. And things look like they are moving fast at Starbase, and that's exactly how we like it.
Yeah,
Rapid
exactly.
Iteration is a key of SpaceX.
Yeah, we've done it with all of our major innovative advancements, including Falcon, Dragon, and Starlink. We believe that if you're not failing, you're not learning and improving the design.
Yeah, many of the innovations that we've developed have come from our failures, and they teach us how to avoid the perils of spaceflight. It's a tough business. But all of this testing, all of the iterative design allows us to make the design better and better to do some of the great accomplishments with reflight that we've had so far.
Exactly. One of the examples that we love to talk about is the Dragon capsule, like the one located behind Shiva and I here on the mezzanine. Originally, it was not designed to be reusable. We wanted to prove the initial design, and then when we brought Dragon 2 online, we had to do a lot of corrosion analysis based on flights that had splashed down and analysis on hardware received there. And now our Dragons are reusable and also rapidly at a much rapid pace than they used to be.
Yeah. So, I mean, great learnings from our original Dragon to our new crew and cargo vehicles have directly improved the operations, and they've helped us change our understanding of what's possible when it comes to rocket and spacecraft reusability. Now, we're just under T-minus 6 minutes, so I think it's another good time to check in with Dan for the rest of terminal count. How are we looking, Dan?
Thanks, Shiva. We're looking good. 5 minutes, 35 seconds, and we're counting down. We are just about at closing the prop load sequences on booster and ship. Just a reminder, ship we're going to close out at around 3 minutes and 30 seconds, booster at about 2 minutes and 50 seconds. Once all of that prop is loaded on board, we'll have about 10 million pounds of propellant on both stages of Starship. Now, after that happens, we'll go through a couple of different procedures with the ground. We'll do what's called pushbacks, clearing out the lines between our prop farm and the vehicles themselves before we get to launch. And then in the next few minutes, we'll get the final guidance system alignments, some final thrust vector control on the booster checks, and all that will be performed. And again, if we need to hold, we have a hold gate built in at T-minus 40 seconds where we can hang out. It sounds like today we'll have about 15 minutes to hold at T-minus 40 if we need to. If we hit that right now, it looks like the most likely reason would be winds. We're not tracking any technical issues to our T0 at 8:25, just about 4.5 minutes from now. So, I mean, everything's really looking good. The booster's almost at full frosty, so we'll see that close out in just a couple of minutes. But we're getting really close to flight, guys.
The excitement is definitely growing here in Hawthorne, SpaceX headquarters. There is a large crowd gathering. You might hear them cheering occasionally. Now, Dan mentioned a good point about the holds. We have an opportunity to today hold for a few minutes. And this is a really cool thing about Starship. And we don't have this opportunity with Falcon or Falcon Heavy. Up until the T-minus 40-second point, aborts are just holds. So anything that would trigger an abort prior to T-minus 40 seconds becomes a hold. So that's a really cool feature to allow the team to wait for final checkouts or assess prop levels, engines, avionics, vehicle pressurization. It's really helpful to ensure a liftoff.
Yeah, and that's something that is very different from Falcon. I'm sure people have watched our launches, and then we get right down past prop load and then have to scrub because of weather or scrub because of an issue on the vehicle. And we don't have the same constraints on our propellant and our system with Starship, which gives us more availability in the window. And sometimes that's all you need. Sometimes the winds dip just enough where you can launch the rocket safely. And otherwise, if you didn't have that ability to hold a few minutes, you might miss that window and then have to recycle to another day.
Yeah, exactly, which is kind of like today. Like we mentioned earlier, winds are the thing that we are watching, so good news there. So we are still continuing to progress. We're looking at liftoff in just under almost 2.5 minutes from now. Super exciting. Like we said before, there's nothing more exciting than watching a test flight for a developmental program, and that's where we're at today.
And like we talked about, we have some really ambitious goals for today's test. But really, the point of today's test is to try to get as much data as we can so we can inform the next iteration of the design of Starship, work those things into flight test number 4 and new objectives there that'll eventually get us to that glorious, rapid, reusable future that we so badly want.
Yeah, for flight 1, we wanted to clear the pad, and we did. For flight 2, we wanted to get through hot staging separation, and we did. So today, we want to get even further than that and collect as much data as we possibly can. So with all that being said, we're going to check back in with Dan to take us through the final 2 minutes of terminal count.
All right, we are under 2 minutes away. We have closed out the prop load on the booster and on the ship. And we're starting to hear some good news that it looks like winds are not going to hold us up, so there's a good chance we blow right through that 40-second hold. So we're about 1 minute and 20 seconds away. Just walking you through one last time, we're going to see the engines ignite about 4 seconds before we hit our T0. They're going to ignite in 3 different banks. You'll get 13 of the inners, 15 of the outers, and then the last 5 ignite just 2 minutes before T0. And then after that, the quick disconnect will retract. The engines will start to throttle up, and then we'll see liftoff about 1.5 seconds after T0. So we're under 1 minute away. Don't be shocked if we hold at 40 seconds before, but it sounds like the winds are cooperating today. And we'll be able to move right past that, not tracking any other technical issues that could hold us.
Proceeding past our QD vent gate.
Through the QD vent gate, past the 40-second hold.
Go for launch.
Flight Director Ty Huntington telling the team we are go for launch. So 20 seconds to go. Let's listen in.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Nominal.
30 seconds into flight, we are feeling the rumble. We are seeing 33 out of 33 Raptor engines ignited on the Super Heavy booster.
Booster and ship, avionics, power, and telemetry nominal. Acquisition of signal, Corpus Christi.
Continuing to get good call outs. Our trajectory looking nominal, systems looking nominal. Just amazing to see all 33 lit up once again. At this point, we've already passed through max Q, that maximum dynamic pressure, and passing supersonic, so we're now moving faster than the speed of sound. Getting those onboard views from the ship cameras. Now the next major milestone is going to be a hot staging maneuver. Again, we're going to be doing that in just about 90 seconds. To do that, we're going to shut down all but the 3 center Raptor engines on Super Heavy. That'll be our MECO, our most engines cut off. And then the clamps holding the 2 stages together are going to release. Starship second stage will ignite its engines, the RVACs first, the sea levels right after that. The sea level engines will be splayed or just kind of pointed out at about a 15-degree angle. So if you look close and we get good tracking, you might be able to see those center right after. And so those 6 engines will push Starship off of the booster. All right, counting down now. We're going to be coming up right at around the 3-minute mark on that hot staging maneuver. Again, we'll see the booster engines start to shut down. You'll see all but 3 lights go out in the middle. And then we'll see the engines ignite on ship, pushing it away. And that will start carrying the ship into space. Booster will start to do its flip and then move into the boost back burn, setting it up for eventual splashdown in the Gulf of Mexico.
Stage separation. Boost back startup.
Hot staging confirmed. Boosters now making its way back, seeing 6 engines ignited on ship. Kate, we got a Starship on its way to space and a booster on the way back to the Gulf.
Oh man, I need a moment to pick my jaw up from the floor because these views are just stunning. These are live views from Starship. First stage is currently performing the
Ship avionics, power and telemetry nominal.
Good there, news informing us that the second stage or the ship, everything looking good, nominal there. First stage is currently performing the boost back burn, expecting that to last about 1 minute. That boost back burn,
pressure is nominal.
that boost back burn propels the booster back towards the coast, taking it to a landing in the waters of the Gulf of Mexico. We're only using the Super Heavy boosters 13 center engines from here on out. As whenever they relight, you'll be able to see that in the left bottom corner. Those are the ones that can gimbal. In other words, they move and change direction in order to change the thrust to steer the first stage back to Earth. Wow, these are just incredible views coming to us. Everything is looking good for both the first stage on the left-hand side of your screen or the Super Heavy booster, as well as on the right-hand side of your screen, that is Starship, or we also refer to that as the ship. Now, the boost back burn was the first of 2 burns required to return it to Earth. The next one will be the landing burn, where all 13 center engines will initially ignite and then transition into a 3-engine burn to help slow it down. Now, just as a reminder of the Stage 1 test objectives, we're looking for controlled ascent, which we have so far. Stage separation, which, gorgeous, we cruised right through it, as well as
on a nominal trajectory.
Good news there telling us that the path that Starship is on is good. Now, Starship's second stage is still firing its engines, and as you heard, following planned flight path. The ship objectives, we're looking for hot staging, again, cruised right through that. We're looking to demonstrate controlled ascent as well as orbital insertion. Now, the bottom right-hand corner of your screen shows the ship engine graphics, so be sure to keep an eye on those.
Yep, Kate, this is just a phenomenal test so far. Super Heavy is performing beautifully today. It's on its return leg of the journey. Ship continuing to burn its 6 engines, those larger circles, the Raptor vacuum engines, the inner circles, the Raptor sea level engines. We're about 30 seconds away, just under 30 seconds away from the start of the boost back burn. The landing burn on the booster. You can see the grid fins rotating. Those hypersonic grid fins are guiding us through the atmosphere back towards our splashdown site. Again, we're going for a splashdown, a soft splashdown. So for landing burn, we're going to expect to see the 13 center engines light, rapidly bring down the booster's velocity, and then just the 3 in the center for splashdown. Let's see if that'll work. We're getting a few engines. And acquisition of signal. Let's see if we can get some other video of that. Now, this is a test objective today. It is still something that we're attempting to learn. And to make it that far, to demonstrate the controlled re-entry up to that point is pretty darn good. Ship continuing to look nominal with its ascent burn. This burn lasting about 6 minutes total. And we're expecting that this burn will end just after T+8 minutes, about a minute from now. So far, though, I mean, congrats to the team. Making it this far is farther than we've gone.
Absolutely.
On Flight 2. Just wonderful views and great engine performance from the vehicles. So far, we've hit controlled ascent. We're in the middle of that right now. We demonstrated the hot staging. Kate, as you said, cruised through that. We demonstrated controlled entry of the booster. Just stopped a little short of the engine relight, but hey, that's something we can learn for the next one.
Yeah. Now that view that we just had moments ago was a live shot of Star Command. There you see it again. This is our mission control center at Starbase, where vehicle operators are standing by. Now the next milestone coming up is in less than a minute. At that point, ship will, or I'm sorry, actually it already has.
Starship engine cut off.
There we go. As you heard there, by the call out and from the crowd behind us,
Starship now open insertion.
Starship's 6 Raptor engines have successfully shut down. We heard a call out for nominal orbital insertion, which is incredible. Look at these views, Dan.
I'm just completely blown away right now. What a day. Congratulations to the entire SpaceX team. I mean, this flight pretty much just started, but we're farther than we've ever been before. We've got a Starship not just in space, but on its coast phase into space. Just to recap where we've come, and it's only been 9.5 minutes. How has it only been 9.5 minutes? We lifted off right on time at 8:25 a.m. We didn't have to hold at our gate at all. We had 33 out of 33 Raptor engines open up and light and get us through a nominal ascent. Another successful hot stage. All 6 engines on the ship propelling us into orbit. We did see what looked like a nominal boost back burn. And then we did make it all the way to the landing burn this time. Didn't light all the engines that we expected, and we did lose the booster. We'll have to go through the data to figure out exactly what happened, obviously. So be on the lookout for information about that. But wow, a ship in space. We've got a bunch of, as we said, ambitious objectives ahead of us. Over the next couple of minutes and pretty much over the next hour, where we're going to really, we've got the ship in space. We're now going to take advantage of this and try and learn as much as possible about some of the other systems, including that first ever Raptor relight in space. So it's just going to be incredible. So all of that still to come. The mission just started, but wow, what a liftoff! What a hot stage! What an amazing sight to see Starship there in outer space.
I can't believe we're seeing it in space. This is awesome.
Wonderful.
And now we are going to be coasting for the next about 30 minutes or so. We'll be back around the T plus 40 minute mark. And that'll be Starship continuing to coast, hit those ambitious test objectives, and then continue on to re-entry. We're not totally sure what video that we'll get, since that normally comes to us as we overfly ground stations, and we don't have a ton of those along our trajectory. But as we have video, we'll be sure to bring that to you.
Starlink may be able to bring us additional communication paths today that will allow us to talk to Starship through re-entry with no communications blackout period. It's a possibility, but either way, we will be live for all of today's milestones. And of course, when we do have views,
Signal, Puerto Rico.
especially like the ones that we have now, which I just cannot get over. When we have views, we will be sure to bring those to you live. But no views or no views, we'll see you back here at T plus 40 minutes.
Pez door is opening.
And there we just heard call it that Pez door is opening, so that's great.
First test.
Yeah. One of our test objectives today is to open and close that Pez door. That's where we will deploy Starlink satellites from in the future. So great news there that test that test objective is already underway. So come back here, stick around till T plus 40 minutes for coverage of Starship's deorbit burn demonstration, followed by its reentry and what is sure to be an exciting splashdown.
Expected loss of signal, Cape Canaveral.
Pez trigger. Expected loss of signal, Puerto Rico. Acquisition of signal, Idris.
Starship's flight computer is in propellant transfer demo. Starship flight computer is in the propellant transfer complete state. Pez checkout's complete. Doors closing.
Afterchill has started.
Acquisition of signal, hard bit stock.
Welcome back to live coverage of our third Starship flight test, which lifted off from Starbase, Texas at 8:25 a.m. Central Time. Our main objective today was to get through all of our ascent burns and collect as much data as possible, including a potential Starship entry. And we just came out of a coast phase and were treated to a number of HD views thanks to Starlink, including the Pez door open-close test. So that was one of our test objectives today that we met. So that's awesome. It has been such a great day.
It has been a phenomenal test day. Just to see booster lifting a Starship to ascent, ship completing its ascent. Just a wonderful day. Kind of to recap the objectives a little bit. Booster completed its ascent, ignited its 33 Raptor engines. We demonstrated a successful hot staging for the second time. Booster completed the boost back burn, didn't quite accomplish the landing burn, and then had a hard splashdown in the Gulf. Meanwhile, ship completely successful after the hot staging. We had a good 6-engine burn of the Raptor vacuum engines and sea level engines. And then we've commanded a number of demonstrations, including the Starlink satellite deploy demo, so the payload door, as well as a prop transfer demonstration. We do still need to do some data review on those, so as we get that data back, we'll be sure to update you on social for how those tests went. We are coming up on our next major milestones, which is an in-space relight of our Raptor engine for the first time, followed by re-entry and then landing in the Indian Ocean.
Incredible.
Yeah, that's right, guys. We should be just about 40 seconds away, 40 or 50 seconds away if we do this relight demo. Do want to stress this is not a deorbit burn. In fact, it's actually going to function a little bit opposite of a deorbit burn. We're going to be raising our perigee with this burn for the lowest point of our orbit. This is just to demonstrate that we can relight a Raptor engine on ship while it's gone through a coast, while it's in outer space, while it's in microgravity, all of the different complexities that come with lighting this engine again after it's already done an ascent burn, but you're now coasting through space. This is going to be really important anytime we want to do in-space maneuvers in the future, like eventual deorbit burns, any of our translunar injections that'll have Raptor engines firing back up. We may not do it. There is all of the guidance is loaded into Starship's computer itself, so if it doesn't see the values that it needs to, we could just skip the burn. So we are waiting to find out if that's going to happen or not. If it doesn't, as we said in the beginning, we're on a pretty steep trajectory that we are coming home no matter what, regardless of doing a burn. This was done just so we can really, we're in a trajectory that's really not super susceptible to delta V changes in velocity. If we were to do a burn, we've got a pretty concise footprint in the Indian Ocean that we're going to be targeting for splashdown today. It does sound like we are skipping past the on-orbit relight demo this time. Again, we'll confirm all of this through our post-flight data review, but it did sound like we did pass through that burn. So now that's going to start setting us up for re-entry.
Yeah, that's exactly right. So coming up next around T plus 49 minutes is Starship re-entry. Now, this is typically a portion of flight where we don't have communications with spacecraft because they're re-entering the Earth's atmosphere at or around orbital velocity, about 8 kilometers per second or roughly 5 miles per second. Super fast. Now, at those speeds, the spacecraft's interaction with the atmosphere results in friction and creates a plasma field around the vehicle. That blanket of plasma distorts communication frequencies, so we're basically left with a brief communications blackout. Now, we might get some telemetry back through a connection to the Tracking and Data Relay Satellite System, also known as TDRS. But if the plasma doesn't entirely block it, that connection will be at a very slow data rate and definitely too slow for any video.
But that's why Starship and Starlink are a great partnership. Starship is so big that it will leave a wake or a hole in the plasma field as it flies through an atmosphere. You can think of a wake kind of like when you see a boat going through the ocean. It sort of leaves a trail behind it. There's some of those great views from Starlink giving us views of Starship's onboard videos. And so we're hoping that the Starlink on board will let us, just like we're seeing these videos now, see through that plasma field by maintaining a continuous communication lock with the satellites on orbit through the wake that Starship leaves behind. Now, this is only the second time that we're testing Starlink during re-entry. So even though we do have these great visuals now, don't be surprised if we manage to get some signal hiccups through. We're still learning about what that wake will actually look like in practice and whether we're able to get that live, continuous, high-speed data during re-entry.
Yeah, that's right. And one of the really primary reasons we want to use Starlink is to just gather as much data as possible. It's been said the data is the payload on one of these flights, where we're putting this flight hardware in a real flight environment, trying to learn about it as much as possible. Re-entry is going to be a really critical phase of flight. We really want to know how the ship's going to perform, especially that heat shield as we're going through the hypersonic re-entry. So if something were to go wrong during this re-entry, we want as many paths as possible to collect that information, that data, just to, again, just continually feed back into the Starship program to make each flight more reliable, more successful.
Acquisition signal, Mauritius.
Now, if Starship manages to make it all the way through re-entry, we'll collect valuable data on Starship flying through the Earth's atmosphere at hypersonic speeds, meaning more than 5, or at this point, will be more than 5 times the speed of sound. Now we're watching these live views, HD views by the looks of it, thanks to Starlink. You can see that the flaps there on the ship might be actuating. Certainly some incredible visions of planet Earth behind Starship. Now, we've already validated Starship's ability to fly and land at subsonic speeds. You might recall those suborbital flights from a few years ago, and we can see those flaps there. So getting data on aspects like heating and control while traveling way faster than we did before is going to be critical to eventually bringing Starships back from space for rapid reuse. So I mentioned those flaps. That's one of the things that enables Starship to help control itself and survive the heat of reentry, which, like we said before, we're expecting that reentry to occur around T plus 49 minutes. So we're getting pretty close here.
And what you're seeing here, it looks like the vehicle is sort of moving back and forth. Part of what you're also seeing is one of the cameras, this onboard view that we have, is on the end of a flap. Starship has front flaps and rear flaps in the vehicle. So we've got 4 of those. And oh man, we can see the heating on those flaps as we're starting to re-enter the Earth's atmosphere. This is where the Earth's atmosphere is doing the work to slow us down.
Now, like we said, this plasma field is, wow, what a view. We hope to maintain these views throughout. Starship is so big that we're hoping that the plasma field doesn't entirely blanket the entire vehicle. Right now, it is not. The Starlinks are
Views
still...
brought to you by Starlink.
Yeah, the Starlinks are still communicating and still capturing the data and the video that we see here. I mean, Shiva, this is just absolutely incredible views. We've never seen anything like this before. This is the biggest flying object ever in space.
Absolutely, Kate. And it's important to note, with the ascent burn that we did was to get us to orbital velocities, even though we were on a nearly orbital trajectory. So the heating and the loads that Starship is going through right now are what it would be getting if it were recovering from an orbital mission. And just the fact that we have views through entry, this is incredible.
Yeah. Again, this is the furthest and fastest that Starship has ever flown. And you can definitely tell by the crowd here in Hawthorne.
The heat shield tiles doing their work. We talked about it earlier. Up to 2,600 degrees Fahrenheit that those heat shield tiles are dissipating as we are re-entering.
Yeah, now this was one of the critical, or rather the key mission objectives that we were hoping to hit today. We have never, like I said before, this is the fastest and furthest that Starship has ever flown. So this is the first time that we're getting to collect this re-entry data and understand how these 18,000 hexagonal heat shield tiles are working together to protect the belly of Starship as it re-enters the Earth's atmosphere. Once again, the atmosphere is doing us a big favor here by...
80 kilometers altitude.
The atmosphere is actually doing us a huge favor here by acting as a braking system for Starship as it re-enters the atmosphere.
And that's part of the reason why the flaps are so important. We're using the body of Starship and the drag from the atmosphere to slow us down from orbital speed, but you want the vehicle to remain stable. You want those heat shield tiles pointed down so they can absorb the heat of the Earth's atmosphere. And so that's the purpose that they are serving during the hypersonic phase and then again during the subsonic phase.
Absolutely. So like we said, these views are being provided by a couple Starlink terminals that are positioned on Starship itself. As that plasma builds, we're hoping that we can bring these views back to you, but you can see the telemetry there on the right-hand side of your screen. If you watch closely, you can see the speed decelerating. Again, that's the friction of the atmosphere resulting in this plasma field, or excuse me, the blanket that is potentially blocking the Starlink terminals right now. So we'll bring those views back to you if we get them. But right now, for those of you that have recently joined, Starship is currently re-entering Earth's atmosphere. This is super exciting because it's the furthest and fastest that Starship has ever flown.
It's just absolutely incredible. Major test milestone, something we wanted to accomplish on Flight 2, getting to it today. So just awesome.
Now, we actually have some heat shields here. So these are what's doing all the work on Starship right now. There are 18,000 hexagonal heat shields like these. So this one that I have is flat, like this is what would be positioned on the flaps of Starship, whereas Shiva has something a little different.
Yeah, the one I have would be on the curved surfaces of Starship. I'll just put it in frame here. So we've got these attached at various points around the vehicle. Like you said, Kate, 18,000 of these tiles around, and they're doing the work to make sure that the structure of the vehicle doesn't carry all that thermal load so we can recover the vehicles eventually and get to rapid reuse on them.
They're really lightweight. They sound a little different than I would have expected them to, but they are ceramic. And these are what's helping Starship survive through this period of entry. We're not sure how far we're going to make it. Again, this is the furthest that we've gotten in our test flight, but the further we fly, the more data that we can get, and that's ultimately the measure of success here, which, I mean, I think today has been a huge success given where we've gone and how much further we've gotten with both the booster and Starship itself.
And one of the beautiful things about Starlink on board the vehicle, we were getting that high-speed video. High-speed video is a very high data rate, and usually video comes after you get your telemetry. So hopefully we were able to get some wonderful data throughout the entry period, which is normally something we have to wait for. until after splashdown when we get that data off the data recorders.
Yeah. Now, you mentioned before the flaps, again, that the flaps are protected by the flat heat shields like I have. There are 4 of those positioned on Starship, 2 at the forward end or the top end, and 2 at the bottom or aft end. And they operate independently to aerodynamically control the vehicle's attitude or positioning during atmospheric flight and enable precise landing at the intended location. So today we are intending to splash down in the Indian Ocean, and we're hoping that we can make it that far, but regardless, it is an exciting end to what has been an exciting day.
Absolutely. And I mean, we've had some tests in the past. We had suborbital campaigns where we have tested out the aerodynamic flaps at subsonic speeds. So that's below the speed of sound. At hypersonic speeds, well, supersonic speeds first, so faster than the speed of sound, and then hypersonic speeds. So that's more than 5 times the speed of sound. The equations of motion change, how the vehicle responds changes. So going through that control phase where we're going from faster than the speed of sound to below the speed of sound was one of the objectives today.
Yeah. And that's actually a great point because we are expecting that entry subsonic period to occur around T plus 1 hour and 3.5 minutes. So we're not there yet. We're about 10 minutes away from that point. So again, that is when Starship would be traveling slower than the speed of sound thanks to the atmospheric braking system.
And so right now we're still waiting to see if we're going to get data back from this ship. We might be in a bit of a blackout period right now. So still waiting to hear the status on it. But yeah, we got to the actual entry portion of today. We started into peak heating, which was just a really big milestone. Starship is pretty unique in the way that it re-enters, especially for something reusable. The closest parallel has been the space shuttle. When we're comparing Starship to like when we bring a Falcon 9 booster back, we're talking about 20 times the energy given the velocity that we're moving at, and all of that energy just gets converted into heat, and then we need to use those tiles to just help dissipate that heat. They're not ablative like you would see on something like Dragon, which uses an ablative in the capsule shape. So they are these tiles that are made to be reusable. So any data we're getting on the actual temperatures it was seeing during heating, all of that is just really hugely valuable. Where Starship is really unique is, and Kate and Shiva have talked about it a couple of times, is once we're through this kind of hypersonic section and we get down to the subsonic. And that's where we really learned a lot and proved that Starship's really just its basic shape could work. And we did that during the suborbital campaign. Again, if you compare it to the shuttle, which entered, it had the wings. It had a similar heat shield system, but it had wings, and then was almost flown like a glider once it re-entered and was down to those subsonic speeds. With Starship, we're not doing that. We're just coming straight down. We'll hit terminal velocity, which with Starship is around 200 miles an hour, and then we use a flip maneuver to ignite those engines, do a landing burn, and then touch down on the ground. So you don't need a runway. We're doing that, again, designed because when we go to the moon, when we go to Mars, there's not going to be a runway there for us, and so that propulsive landing is going to be really important. This is an animation of pretty much what we were just watching on actual Starship video, which is pretty incredible. But we go through peak heating. One of the benefits of today's trajectory, actually, we got closer to what the heating profile will be on just a normal mission when you compare it to our previous flights, which were headed out to Hawaii. So we go through peak heating, and then we hit subsonic, and then Starship splashes down in the ocean. Again, we're not doing a landing burn on this flight, and we're not expecting Starship to survive the impact. We're not going to be recovering any of the hardware. For now, though, we are just still waiting to see if we're going to get some signal back. We're currently at a loss of signal with Starship. Don't know for sure what its status is, and so we're just continuing to listen in. But it was pretty incredible seeing the flaps really do their thing to maneuver the vehicle as it's moving through hypersonic. One of the big trade-offs between something like Shuttle and Starship is wings can be pretty heavy. And so if we can really demonstrate that Starship's controllable through that hypersonic regime when you're coming through the atmosphere, 25 times the speed of sound, you can save a whole lot of weight by not having really big wings. So super valuable to get this data, super valuable to then figure out what we're going to do on our next test flights.
Yeah, and you'd brought up a really interesting point, too, that for on shuttle, you are gliding in, going back to a runway. On Starship, because we're landing vertically, we are basically coming down, and then we've seen this during the suborbital campaign. We're not going to see it today, but during the suborbital campaign, we did the flip maneuver and then light our engines for a landing burn. And that's also really important for some of our other terrestrial destinations, that we don't have as much of an atmosphere on Mars. There is pretty much no atmosphere. There's some great views from our previous test campaigns of a landing burn and upright landing. But on the moon, there is no atmosphere. On Mars, the atmosphere is extremely thin, so you actually need some other sophisticated techniques that other landers have used to land there. And so this vertical landing technique is really important to landing on destinations like those, which is ultimately where we're trying to go.
Yeah, absolutely. So we hope to demonstrate that landing in future missions. That wasn't one of our objectives for today. We wanted the ship to focus on opening and closing, the first demonstration of opening and closing the Pez door, which is where we will deploy Starlink satellites from in the future, as well as gathering data on how the heat shield tiles performed during the entry period. And so far, all of that has gone really well. So overall, it's been pretty great. And it's great to see how those initial tests that we performed a couple years ago for those high altitude tests allow us to see what those will look like in the future. But this piece that we're doing today of, okay, if we are coming back from orbital velocity and we're going through that entry period, that is the missing piece, right? We already figured out how to land once the ship gets to a certain velocity or altitude, and it's really this piece that we were trying to figure out today. How do we get Starship to survive orbital velocity atmospheric entry? And we hope to find out soon.
Yeah, I mean, we talked about rapid iteration and how we do design. Part of our philosophy is testing early and often and trying to test in a way that is as flight-like as possible. But there's only so much you can do in a chamber where you're trying to simulate the atmosphere in a laboratory. So there's nothing quite like when the heat shield tile hits the atmosphere in flight to gather that wonderful data and prove out some of the analyses and probably teach us a bunch of things that we didn't quite get right.
For sure. And obviously, for those of you that have been watching along with us, those were incredible views to see of that entry period where we saw the heat generating because of friction as the belly of Starship was making contact with the Earth's atmosphere, and that resulted in some plasma. So as Dan said before, we believe that we're in a bit of a blackout period at the moment. We are expecting the vehicle, if it's still alive, we would be expecting the vehicle to be approaching subsonic or slower than the speed of sound speeds in 3.5 minutes from now. So if it's still up there in one piece, it still has a way to go. We're not there just yet. But we saw that plasma field building up around the exterior, which can blanket the entire vehicle as it does with all of our Dragon missions, and we're at a loss for telemetry at that point in time.
Yeah.
So
Dan's seen a lot of those with Dragon missions that he's supported.
Yeah, absolutely.
And we are hearing through some of the telemetry that we did. It did look like we lost Starlink and our TDRS data flow at the exact same time. Now, if both of those signals are cutting out at the exact same time, that could mean we lost the ship. It has been several minutes since we've gotten any data from Starship. We are waiting just a couple more minutes just to see if we can get any additional confirmation, but that is one data point that we're tracking, and that could indicate that we had a loss or a breakup of the ship during that reentry. So might not make it all the way to splashdown today, but we were able to get through the early phases of reentry, hit some of that peak heating, which was just really incredible to see a Starship coming back from space after getting all those views from space for the very first time. So we'll just keep on listening in on the loops here, see if we hear anything over the next couple of minutes, and that might bring a close to a pretty successful day so far. So again, we did lose the TDRS. That's the tracking and data relay satellite. That's the satellite system that pretty much every spacecraft operating in orbit right now will use to get data. We were able to get some signal through that, and then we were also getting data back through Starlink.
Live view here of mission control down at Starbase. So these are all the folks who are experts on the various different systems, taking a look at the live data that we did have. Probably in mission mode still,
Yeah,
but
absolutely.
it would be so tough to stay focused with what an exciting day we've had today.
Yeah, to quote Monty Python, I'm not dead yet. We don't know, as Dan said. We did lose connection with TDRS, which is the tracking and data relay satellite system, and Starlink at the same time. So it is a realistic possibility that we lost Starship, which honestly was always on the table. We didn't know how far it was going to get. The further we could fly and the more data we could collect was always the biggest win. And so regardless of, if we did lose the vehicle and we are not able to, make it all the way to our intended splashdown, note that we weren't intending to recover this vehicle, either vehicle, the Super Heavy booster nor the Starship. We weren't intending to recover either of them. They were both going to basically hit at terminal velocity and break up upon contact with the surface of the ocean. So we're standing by to hear whether or not we are going to be able to get telemetry readings back, but we are possibly anticipating news that we lost Starship due to basically a double blackout from TDRS and Starship data at the same time.
But it's worth mentioning, this is the first time that we have come back at these speeds
Absolutely.
in any of the test flights that we've done so far with Starship. So we are trying to prove out that the heat shield works as intended, that the controllability at those hypersonic speeds works as intended. So if we were able to get back any data on that, that means the next version, what happens on flight 4, 5, 6, is going to be better.
We must be able to get some because we saw incredibly gorgeous high definition views of that entry period whenever it was initially starting. So we must have gotten some data
today
there.
has been otherwise a phenomenal day.
Incredible.
Liftoff on time, full ignition of all of the boosters, engines, successful hot staging, and then ship took it from there.
Yeah, absolutely. We were able to see the ship actually make it further as well as the booster. We were hoping that the booster would perform a soft water landing, but we lost it during just before it was able to ignite the landing burn. But the ship continued on. We saw all six Raptor engines on the ship ignite and then shut down for second engine cutoff. And we saw some amazing views as well, and it's just been certainly a day that I will be taking many screenshots and using them as my computer desktop background for, until the next Starship launch.
When we get even better views, I'm sure.
Exactly.
And we also hit a number of our other ambitious test objectives. We had a chance to at least initiate the commands for a propellant transfer demo within the vehicle. This is something that Starship's going to have to do in the future, and these sort of transfers haven't been done at this scale before, so that's a first as well. We also were able to demonstrate that the payload door functions.
And we got to see that,
Yeah, and so those commands were sent. Again, data review to come and make sure that everything performed as expected, but that's going to be critical to deploying payloads in the future once Starship becomes operational. So a number of test objectives hit, much more accomplished than Flight 2, and making steady progress towards a fully, rapidly reusable, reliable Starship.
Absolutely.
And hey, Kate, and hey, Shiva, we were just hearing on the loops, we are making the call now that we have lost Ship 28. So as we were possibly expecting, we lost the data a couple of minutes ago. We haven't heard from the ship up until this point, and so the team has made the call that ship has been lost. So no splashdown today, but again, just it's incredible to see how much further we got this time around. We had a couple of those ambitious objectives that you guys were just walking through that we're able to take advantage of while Starship was in outer space flying over our planet for the very first time. So that was just really incredible. Obviously, there's a lot to go through. Everyone always wants to know right off the bat what happened. Takes us a little bit of time, but I can assure you as soon as we start finding things out, we're going to let everybody know. And I know everybody's going to be excited for the next one. I mean, as I pointed out in the beginning, there's 4 super heavy boosters either fully stacked or getting stacked right behind me. We've got other ships ready to go as well. So it's going to be a really busy time down here at Starbase as we look to really fly Starship as much as possible, get this vehicle ready to go for all the important things it's got to go do.
And with that, we got to say a huge congratulations to our teammates and everyone who's supported the Starship program. There's been flames and reds along the way, but third time's the charm, and we made it to space. We also a big thanks to all of our future customers for your support. And we want to give a big thanks to the people of Cameron County, Texas, for their support, as well as the Coast Guard and the Federal Aviation Administration.
Be sure to follow the SpaceX account on X for more updates from today's test flight and future Starship tests. But before we go, we want to wish SpaceX a very happy birthday. The company was founded on this day in 2002 when it basically consisted of this small team, a carpet and a mariachi band. I don't know about you, but we're feeling 22. Also, it's Pi Day.
Yeah, but I mean, Pi Day is constant and never ending, so shouldn't every day be Pi Day from now on?
I mean, that's a really good point, and I think after a test like today's, we all deserve some pie.
Thanks for watching, and we'll see you next time.